problem in this section, number 41. The instructions say simplify each expression by factoring. So what can we do to factor this? Well, this one's a little bit unusual, and it's kind of vague why you might want to factor this, but you know, at least we can factor something out of here. When we factor, there are several ways to factor, but one of the things we kind of look for to factor is a common term in one or more expressions that are added together. Okay, so you can look at this and see pretty quickly that they both have x plus 1 to a power in them. Okay, so that means that x plus 1, or at least some amount of x plus 1s, can be removed out and factored out of both of these. Okay. Well, actually, now that I look at it again, there's something else that can be factored out. Both of these expressions contain a factor of 3. Okay, so you could do this in 2 steps if you want. It may not be a bad idea to kind of make it a little bit simpler of a problem. But if I take the 3 out of both of these, okay, it'll leave me x times x plus 1 to the 3/2 power. Okay, but 3 comes out of the 6. 6 goes into 3 2 times, so it would be negative 2 times x plus 1 to the 1/2. Okay, so look at what I've done here. I've actually factored 3 out of both terms, because 3 does factor out 6, and of course 3. Okay, but what else factors out? Well, some x plus 1s factor out. And this is the weird thing. Since we're raising to a power, basically we can remove the common number of x plus 1 factors that is in both of these expressions. And 3/2 is a larger power than 1/2, so they have, at least you could say, x plus 1 to the power 1/2 in this term and this term. Okay, so we can factor that out as well. So I took out the 3 from both of these 2 terms, and now I'm taking out x plus 1 to the 1/2. Okay, now here's the good issue. What's left over when I do that? Okay, well, from the first term, I didn't factor out that single x. It's still there. But since I removed a half of these x plus 1s, I'm just going to have a single x plus 1 left. And let me explain that. Okay, if I were to multiply this back in and combine it with this term, we see that that has to be x plus 1 to the power 1. Okay, because when I multiplied x plus 1 to 2 different powers together, I would add the power to get the exponent 3/2. So if I take out a half of a power of x plus 1, I would have x plus 1 left, or x plus 1 to the first power. Okay, so basically distributing it back inside and combining with this term, I would now get x plus 1 to the power 1 plus 1/2, which is 3/2. Okay, so this is just x times x plus 1 after I factor out the x plus 1 to the 1/2 power. And here, I just have minus 2 because I factored that whole term out, sitting right here. Okay, all I had was x plus 1 to the 1/2 sitting next to the 2. Okay, so basically this is done. I think, you know, given just kind of what they do in the back of the book, we've kind of done all the true factoring we can do. 3 times x plus 1 to the 1/2. And this really isn't factored. This is one thing factored, but we're subtracting 2 from it. So in the book, they would probably multiply this back together. And when we do that, we get x squared plus x minus 2. Okay. So we've done the main amount of factoring now. Not quite done yet. And again, keep in mind, these are just practice problems for factoring. We can go a little bit further. This is 3 times x plus 1 to the 1/2 power. Okay, but this factors further. This is a trinomial. You might remember factoring these in algebra. Okay, this is x squared plus x minus 2. This happens to factor as x plus 2 times x minus 1. Okay, definitely no more factoring can be done in this problem. That would be your final answer.